Alright, so first, number 1. He gives you this table and he says, come on, B5A. He says the density of the table is 850 kilograms per meter cubed, and he wants the weight of the table. Okay, so what's the formula for weight? Mass times gravity. And what's the formula for mass? Well, remember, density is mass over volume. So what's mass? Density by volume. So this is rho Vg then. Density 850. Volume 1.2 times 0.3. Who's that, Chris? Times 0.04 times 9.81. It comes out as 120. Please. What's wrong? Are you sure? Okay. That's part A. Alright, B1. On top of this table, so there's A, there's B, you put a vase, like a block, okay? And the block is 0.4 of a meter from A. And the block's mass is 5.1 kg. And he wants the reaction at A and the reaction at B. So let's draw in our forces, okay? We haven't put in the weight. So there's a weight here of 120 newtons. And also, Brandon, do you mind doing 5.1 times 9.8 to get the other weight?
It's 50.
What is it? 50 newtons. Now what are the upward forces? There's a reaction here. Yeah, and what else? Reaction here. I'll call this R and S. Okay, so let's see. Abdulaziz, you can tell me. So what can I say about the forces here?
Which forces?
All the forces. Are they balanced? Yeah, they should be balanced. They should cancel. So can you give me an equation here? So I'm thinking R plus S. What should that equal? 50 plus 120. So I get R plus S. What should that equal? 170. Now, the problem is I need another equation. What could I use as my second equation? No? Who's this now? What took you so long? What's my other formula I could use here? Turning force. Turning force. So, where will I take the turning point to be?
The middle 120.
Middle, maybe, but I'm going to take. Oh, by the way, I didn't write it in. These distances here are 0.15 and 0.15. Okay. Anywhere really. Shall we take the point at the very beginning? No, actually, you know what? I'm going to take this point because it will cancel one of the reactions. Okay. So that force is gone. This force, clockwise or anti-clockwise? Clockwise, and the turning force is 50 multiplied by 0.4. That's the distance, okay? Clockwise or anti-clockwise? Clockwise also. And what's the distance? Well, the distance from here to here, if you look at the picture, how long is this table? 120, okay? So 1.2 minus 0.15 minus 0.15 divided by 2. The distance from here to the center, I worked it out as 0.45. So it's times 0.45. And then that should equal this anti-clockwise force, which is S, and the distance is 90.9. Because I just said that this whole thing is 0.9. Like he says the whole table is 1.2. So 1.2 minus these two pieces gives me this piece in the middle. Yeah? Okay. This gives me S equals 82.3. And then if I substitute that in here, I get R equals, yeah, which, oh sorry, no, yeah, 170 minus 87.7, no, minus 82.3, which is 87.7. Okay, that is the reaction force at A and the reaction at B. Actually, this question is quite short because the next one here, you have an iron cannon of mass 6.4 is fired from the top of a building at velocity 80. The building is 28 meters tall. And it goes crash. And the velocity is 80 meters per second. The mass is 6.4 kg and the velocity is 80 meters per second. Oh, sorry, I drew this wrong. It's fired horizontally, which means it just shoots straight out, like a car driving off a cliff. So, here's your building. It's 28 meters high, and the cannon goes straight out like that. Oh, sorry. No, just, goes like that. It is 6.4 kg, and its velocity is 80 meters per second. How long does it take to hit the ground? So, what formulas? The Suvats, yeah. Now, I'll look at the vertical first. So, vertically, what's the U? Very good. What's the G? Oh, sorry. What's the A? 9.81. And what's the S? 28. If you took minus 9.81, then you should use minus 28. Okay? Don't worry about that. It's okay? Okay, alright, sorry. It must have been...
I said...
Forget about it.
Yeah.
Right. Okay, so we have S equals UT, which is 0, and then a half A T squared, so T equals 2.39 seconds.
3 months.
Yeah, I know. For babies.
Are you copying?
Yeah, you missed the question. He missed the question earlier that was for 6 marks. Remember that? In question 1, the battery.
Today in chemistry we had a question 9 marks only for.
But was it
Yeah,
easy?
yes.
But was it easy?
Yeah.
Was it?
Everyone was easy. For everyone.
Okay, good. So think smart about it. All right. Next part is how far does it travel out from the base? So again, what do we use? Suvat. So what's U? Horizontally. What's U? 80. Horizontal. What's T? 2.39. What's A? 0. Horizontal.
But
So-
isn't there acceleration when the thing throws it off?
No, and of course there'd be acceleration due to air as well, but you don't. Yeah, you don't. You just assume it's constant horizontally, although it's not really going to be. What's the formula? S equals UT. So what does that come out as? 191 meters. Calculate the kinetic energy when it strikes the ground. Half mv squared, yeah? Yeah, but you have to be careful about the... You have to be careful about the V, because there's actually 2 V's, the horizontal and the vertical. Now, we know what the horizontal one is. What's the horizontal? It's 80. It doesn't change because it's always 80 horizontally. There's no acceleration. We need to work out the vertical. So that is, what's the formula for velocity? U plus AT. What's the U? 0. What's the A? And what's the T?
2.39.
So what is this equal to? Was it? Now, this is going down, so I really should put negative. So for the next part, I'll just put in the negative. The velocity equals 80I plus, minus 23.4J. Now, what do we need to use in the formula? V squared, right? So first we need to get the magnitude. So magnitude will be, what is it? Root, yeah. Plus,
Minus 23.
yeah, but the minus will be squared, so I'll just put in plus. $83.35. And then, so you get kinetic energy equals a half v squared. But in, yeah, what's that actually? It should be something like 22.2 kilojoules.
Yeah.
Now, in fact, there is another way to do this. Who can tell me the other way to do this? Come on, please. Oh, come on, come on, come on. Wake up. I know it's been a long day, but come on. What? No. 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 Another way to get the answer. C, D, what? No, no, no. Energy. The energy here must equal energy here. What is the energy here? It's the potential. So let's write it down. We'll do it. 28 times 6.4 times 9.81 plus the kinetic. And what's the kinetic? A half m v squared. Now please calculate this. This is the energy at the start. Yeah, 22.2 kilojoules. Now think about this for a moment. At the end, what energy is there? Is there potential? No. So what is it? Kinetic. And what will that energy equal? It will equal what? Yeah, the first energy, which is what? Potential plus kinetic. So which was easier to do? This method or this method? This one, of course. So please think before you start a question. Is there an easier way to do it if it seems like it's too difficult? Yeah? Oh, by the way, sorry, just to say, in the marking scheme, in fact, they did it the more difficult way. But if you figured out how to do this the easy way, which is those two lines, just those two lines, you get 4 marks. So if you work out the energy at the end, it equals the energy, the energy at the beginning, it equals the energy at the end, and there's only kinetic energy at the end. Okay?
So,
Yes?
I have the half and v squared equals NGH for the other way.
No. That one, it doesn't work here. That one only works when there's only potential at the start and no kinetic, and then only kinetic at the end and no potential. So here it's kinetic plus potential at the start equals kinetic at the end. Yeah? Is it okay?
Yeah.
Right. D. Why would the kinetic energy of the cannonball be different from your answer to C if you include air resistance?
Less acceleration.
No, come on. Hey, come on. This is the last part of this question, and then we're going home, okay? So please focus. Yes. Why would the kinetic energy be different if there is air resistance. And I don't really want any mention of acceleration. I prefer a different answer.
Because some of the energy is lost due to friction.
Not friction isn't really an energy due to
Air resistance due to heat.
due to heat that's caused when the cannonball has the air friction. So kinetic energy is lost to heat caused by the air resistance.
Same thing.
Yeah, but you just want to make sure you use the terms correctly, because friction isn't an energy, so you can't really say, I know it sounds like it makes sense that kinetic energy is converted into friction, but energy is joules and friction is newtons, so you can't really say that. You have to say the kinetic energy is lost to heat energy, and the heat is produced by the friction between the air and the cannonball. Just like that, huh?
Yeah.
All right. We will get number 6 finished at the start of the next class, and then we'll look at one more exam. I may try to do an extra class this week if I feel we need it, and then if I manage the extra class and the extra exam, then I've done 4 years of papers with you. You have more papers to